Hello, everyone, and thanks for tuning into day 2 of our Science on a Sphere Earth Day show. So, to celebrate the 50th anniversary of Earth Day, we're releasing a video every day leading up to Earth Day talking about how scientists monitor the Earth. So, yesterday we discussed satellites and their positions in space. So, if you didn't catch that one, I would highly recommend going back and watching it. But today we are talking about satellites that carry infrared light sensors and what they can tell us about the Earth. So remember, tune in every day for some new Earth Day content. But let's go ahead and get started. So if you weren't here yesterday, I want to remind you all that what you're seeing this data set of the Earth displayed on is an app that you can actually download for free called the SOS Explorer App. I believe it's available for both Apple and Android. So it shows us the whole Earth with North America, South America, Africa, Europe, and then we have Asia and Australia in nighttime currently. And then here's that day-night terminator, or just that dividing line between the day and night. So this is a pretty cool app to study geography as well as to study the Earth. There's a lot of cool data sets that you can take a look at. But the one that I'd like to show you today So the dataset that I'd like to show you today shows our hurricane season in 2017. The 2017 hurricane season is one to remember. There are quite a few very, very bad storms that happened, so that's why I thought I'd show you it. But I want to talk to you all first about how we actually got this dataset in the first place. So of course, feel free to watch this video as it goes by. But all of this data for this data set comes from a few different types of satellites. One are the GOES satellites that NOAA uses that stand for the Geostationary Operational Environmental Satellite. I did mention them in our last video. And then some of the other satellites that are used are the Himawari satellites that are Japanese weather satellites that are also geostationary weather satellites. So like I said, if you missed out on the last video about satellites, I will talk about geostationary satellites. All this data comes from those satellites, and the sensors that are used are infrared and visible sensors. So of course visible light, that's what we see, but infrared light we cannot see. We can perceive some infrared light as heat, but we with our own eyes cannot see that. So that's why we have satellites that help us with that. So infrared light can tell us about an object's temperature. That's what it's primarily used for. So with weather satellites, it helps us figure out the temperature of either the cloud tops if there's cloud cover, or of the surface if there is no cloud cover. So the assumption that is used with infrared data is that the temperature of the cloud tops decreases with the height. So that basically just means that the cooler the temperature, the most likely the higher up that cloud is in the atmosphere. The further you go up in the atmosphere, the colder it gets. Now, unfortunately, infrared data does not tell us about the thickness of the clouds or any precipitation that comes from them. And you should not confuse this with radar, which I will be talking about later. Radar will actually show precipitation. So do not confuse infrared data with radar. If you are confused, make sure you look for units on your map. Infrared maps will normally have a legend with temperature as their units and not something like precipitation, so the amount of rain or something that you're going to get. So as you can see with this data set, infrared and visible data combined together help us see cloud movement. So like I said, this is the 2017 data set for hurricanes. And there's, if I can pause it, that's Hurricane Harvey. Hurricane Harvey was basically the first of many very, very strong hurricanes that hit in 2017. Harvey hit Texas. Now, the thing about Harvey that made it so devastating was that it had a lot of precipitation. It was the wettest tropical hurricane on record in the U.S. There you can see the eye of the storm. Like I said, they got Texas, where Hurricane Harvey hit, got about 52 inches of rain, which is crazy to think about. And that's why Hurricane Harvey was so devastating, is because of all the rain that it brought. Our next storm that'll be coming up that you'll be able to see very, very strongly in detail is Hurricane Irma. Hurricane Irma had the highest sustained winds, so it had about 185 mile per hour winds for 37 hours. So it was definitely a Category 5 storm. And I believe this is Irma coming up here. There you can see that eye coming across. So this data set is really, really nice for us to see the entire hurricane season for any particular year. So there's Irma, and the one that's coming up behind it, this one right here, this is Hurricane Jose. It wasn't all that strong, but it did actually hit the U.S., just not in Florida. It actually hit the eastern seaboard. It hit the New England area, so you'll see it kind of travel up and hit New England. And there it goes. And then our last really, really bad hurricane of the year was, of course, Hurricane Maria that devastated Puerto Rico. It was the most intense tropical cyclone to ever strike the U.S. in recorded history. Just a beautiful, horrible hurricane. And there's another little small one right back there. I don't know what hurricane that one is. But like I said, this data set actually covers most of the Earth. So you can actually see typhoons, that's what they call hurricanes over in the Pacific. You can actually see some of those form out here as well. So I would highly recommend checking out this data set. There's a lot hidden in here. So if you're interested in storms or anything like that, I would highly recommend just watching this data set and looking for all those cool storms that you can see. So thanks for tuning in for our first talk about infrared data. We'll be talking a little bit more about it tomorrow, and I'll be showing you a different data set. So thanks for tuning in for day 2 of our Science Ionosphere Earth Day chat, and I hope that you tune in tomorrow. Thanks for watching.